When you are comparing two designs, you want it to be done quickly and successfully. In some designs, the differences between them can be enormous. If you have a lot of don't cares, or if you have large cones that have typically differences that cannot be easily resolved, or if you have many inputs to each cone, what could happen is that the comparison of these large cones can increase your runtime. To address this increased runtime, what the tool does is assign a specific amount of time on a specific compare point. To move forward, the tool aborts this comparison and moves on to another compare point. Aborts are nothing but compare points that haven't been conclusively compared at this point, and the tool has moved on by the time aborts are reported. Conformal has tried different things and still cannot conclusively say the result is either non-equivalent or equivalent. It cannot determine either. This inability to generate a conclusive or deterministic result is because the tool wants to save on runtime and move on to other comparisons that it needs to do at the other compare points. Keep in mind that aborts are something that the tool is doing to save on runtime. The best method for handling aborts is to avoid them in the first place. There are ways to imply the use of equivalence checker-friendly coding practices or the modularization of large cones of logic to avoid these aborts. Let's look at some of these best practices. When you write your RTL, it would be helpful for equivalence checking to always think of these guidelines, mainly to avoid aborts. First, do not write too large a Verilog module. Keeping it small will help with the comparison. The same is true with creating hierarchies, they make the comparison easier. In situations with difficult arithmetic operations, it will help isolate your aborts. During synthesis, always remember that ungrouping and inverter pushing will cause a comparison to be difficult. Always separate out ungrouping from other optimization tasks. Your comparison will be much easier between the optimized netlist and the ungrouped netlist rather than combining it all into one. The idea is to simplify your verification and not do all the tasks at once. Beware of inverter pushing, because the return on investment may be minimal considering the amount of time you spent verifying your designs versus the improvement in timing results. Another recommendation is that you must avoid using X's or don't cares in your RTL. Minimize using a full case, parallel case, or default X's, as these will create X sources in your design and therefore cause aborts. With the RTL guidelines established, it's not always feasible to follow those guidelines, especially if your RTL has already been done. Now you are in the middle of equivalence checking. We recommend that you follow these steps to resolve your aborts, such as reporting on your design, which compares the two designs and reports a degree of similarity between 0 and 100%. The more similar the two designs are, means the more corresponding points exist between the two designs, and it is easier for a comparison. To help you determine how many aborts you might run into or what kind of difficulties you might face during your comparison, run report design similarity. You will see the structural differences between the two designs as a number. This will give you an idea of how much optimization has been done on your design and if you will be running into any aborts. If the similarity is low, the tool could possibly run into aborts. In this case, it shows a 30% similarity. A similarity of 30% is a good percentage of similarity for most designs. So, this comparison might not have any aborts. If you're not able to avoid aborts, then you can run the analyze commands to help resolve some of your aborts.